And thank you for allowing me to intrude on your day. This has been a great presentation so far. And my focus really is on kind of some North American efforts related to voluntary programs that are either based or very similar to Zhaga Book 20. I do think it's important, as we've been talking about the circular economy and sustainability, of moving into this standardization of just the small widget parts to allow for flexibility and interoperability. At least too often in the North American market, many manufacturers try to differentiate and use that as their leverage. And as a downside, you can't replace products or even components very easily if a manufacturer goes out of business, or if there's a change in technology very easily, and it ends up having to change, in some cases in the US market a lot, they have to replace the entire luminaire. And so I think it's really important that we start looking on these small standardization efforts that seem small at the real mechanical level, but can have a greater role. So I'll be touching base on, as mentioned earlier, 2 US Department of Energy related efforts, and then one that's somewhat related, but very similar to the Zhaga program that is occurring by the National Electrical Manufacturers Association. And as mentioned, I am across the pond, and all of this is focused on really North American efforts. So the first thing I want to mention is something known as Elprize. This was actually something that was briefly presented by the Zhaga Consortium earlier this summer as well. They were very nice to host a webinar related to this, so I just want to mention it again. The idea here is the US Congress incentivized, is really many years ago, a next generation lighting competition, and the idea is that there's a financial prize for a manufacturer or practitioners that develop kind of a very far cutting edge technology. And there's a couple of phases. This is similar to if you're following US policies or other things. The Elprize had a standardized lamp or light bulb back in around 2010. That was a competition as well. And there was, again, a monetary prize really trying to get manufacturers and technologists to really reach as far as possible in terms of how innovative they can get. So as I mentioned, it's in 3 phases. Currently, we're in phase 1, which is concepts. Then we'll be moving into phase 2 for actual prototypes. And then finally, we'd like to see actual products installed and validated. Why it matters related to this this overall conference here is you can see these are the major consistent technical requirements for Elprize. In the US, and I think probably in Europe, we're all kind of getting used to and very comfortable with high efficacy products. This does try to push a little further on that. But this also looks at some of these other aspects, such as quality of light. But you also see that product lifecycle plays a large role. And in this catalog of characteristics, a check mark is a requirement, and a box indicates that they can get additional points. So again, designed for disassembly, circular economy, they have incentivized criteria for that for this next generation fixture. We don't want to incentivize a cutting edge that then just replicates some of the problems we've had on the manufacturing and disassembly side. The other thing that they're offering incentivized points for is this sensor ready and upgradable category. And that's what that's shown in the yellow highlighting. And I blew it up so you can read the points. Here, they're trying to focus on this D4i driver, which is somewhat Dali or Zhaga adjacent, but that's something that North American also has an equivalent known as ANSI C137. So we're really focusing on that standardized driver communication and data protocol, but then also they can get 1 point for luminaires that use the Zhaga Book 20. So again, the idea here is there's a financial incentive for manufacturers that really developed a cutting edge forward-looking fixture, but we don't want to leave out these small components, such as how the sensors actually fit in the luminaire and how the data is exchanged. So that's one program that's going on right now, and we'll go through roughly 2024. The other thing that I want to mention is this voluntary program that we're about to announce in the near future. The image on the left is kind of representative, again, of most of the North American market, that you can get any kind of configuration of sensor. They often come in rectangular, circular, or kind of some oblong shapes. The challenge is each one is a different size, and that's the problem. And that's ultimately where, Zhaga Book 20 comes in and plays a role. So we're, I like this old cell phone analogy as kind of an example of 15 years ago, every time someone had a new cell phone, often the connector base was different, requiring all new types of interfaces every time you got a new phone, just generating waste. and limiting some of the innovation we can do. And that's where we need to get to in lighting. We moved away from that in the mobile phone market. We need to move that forward that, as well as we actually had the same problem in computers and PCs. We really standardized on that in the USB technology and similarly. So there's a history in consumer electronics of standardizing on the same electrical and mechanical interfaces, which allows for innovation. And that's ultimately what we're trying to do with this, what we're calling the IoT Upgradable Lighting Challenge. When announced, the idea here is to really make controls and sensors more accessible to a broader set of users. So the idea is really trying to focus at that widget level and to really get manufacturers to lean into how hard would it be to them adopt a Zhaga Book 20 type of interface in a standard fixture. In the US, we've also asked for a slight, a reasonable price increase, and understanding that it is a slight deviation. So this is kind of how the challenge approach works. We put it out there, and ideally manufacturers respond, and it's a market pull opportunity to demonstrate that there is interest on it by end users, and therefore manufacturers respond. Along the way, as we were developing this performance program and voluntary program, we looked at both Zhaga Book 20 and then this NEMA document, which is actually in the very final stages. They just actually emailed me today. So this is just abbreviated as LSD. This is one of their documents. So they have a similar kind of concept of a standardized interface for control developments. Many of theirs overlap with the Zhaga shape. This was developed by NEMA manufacturers. So again, that's a North American focus. It does include some out-of-scope analog sensors, so it has more categories than the Zhaga Book 20. And one concern could be that too many or proprietary shape and size sensors may affect future upgradability. So that's always a concern as you get to too many shapes and sizes. For the challenge that we are going to be announcing relatively soon, we surveyed 20 North American manufacturers and actually reviewed over 60 sensors. And some of the data that we acquired in the process, we actually supplied both to the Zhaga Consortium and NEMA to help them inform their documentation, which we'll talk about in a second. Ultimately, this IoT challenge is going to focus on the 4 Zhaga shapes and then 1 NEMA shape. This is really more for your high bay fixture. It's something the Zhaga Book 20 doesn't have right now, but what happens if you have a sensor that actually needs to be outside the luminaire, but still needs to have a standardized interface? And that's one that the NEMA category does. Again, the end goal here is really encouraging standardization and reducing upgradable uncertainty. And that ultimately benefits the entire process and sustainability by not having to change every time you change manufacturers, or worse, even technology. So you're all familiar, I hope, but if not, I'll just touch base on it. Zhaga Book 20, it standardizes on the physical and electrical interfaces, and that's going to be a detail that I'm going to come back to in a second, the electrical and physical. And then there's the shapes and sizes. So and then ultimately it has to work with the D4i driver as well. So that's a kind of the standardized Zhaga Book 20. So this is the NEMA version, which again is similar but slightly different. They're standardizing the physical connection. They have roughly 10 to 12 sensor type options. 4 of them directly overlap with the Zhaga standard. Where they significantly differ was there was a little pushback on a standardized plug connector. So while Zhaga Book 20 specified that, and we ultimately think that's a good idea, because even though it's 2 wires, that's still a chance for error or confusion. So having that standardized wire interconnection, again, makes things easier, and just it allows for upgradability. Also, the NEMA document really doesn't address the D4i driver issues yet, or benefits, actually, I should say. So this is where they are, and as I mentioned, this document is being developed and finalized, from what I was told, by NEMA quite literally today, and so this should be available publicly, at least in the North American market, very soon. One of the things that was interesting in the process as we analyze all the sensors is we compiled lists of 60 North American manufacturers. Many of them also have European counterparts or subsidiaries or even parent companies. We looked at 66 sensors across these North American manufacturers, only focusing on ones that would go in the luminaire, that were low voltage, or a dolly connection. And what was interesting is that when we looked at and held the specifications for the tolerances for the areas and the set asides and the keep outs, for both NEMA and the Zhaga document, we found that in the NEMA document, about 50% of the sensors we found were compliant, which makes sense because NEMA is North American focused and Zhaga is more international. What was the challenging thing, and you can see this over in the right-hand image, is this known as the external keep out. So the Zhaga standard, as well as the NEMA one, had a limit on how large the sensor could be outside the luminaire. And ultimately, that has really a limited negative impact on how the sensor performs. It can cause some line of sight issues or some other parameters, but ultimately, that external keep out was actually limiting a number of sensors from complying with either the NEMA document or the Zhaga document. Even though some of their own manufacturers were helping writing this document, some of their sensors weren't even meeting their requirements. If you exclude this keep out, and sometimes we're talking about just a few millimeters difference, you can see that a majority of the sensors in North America meet both the NEMA document and the Zhaga standard. So this is a kind of a thing that we supplied to both Zhaga Consortium as well as NEMA, showing that this one small thing was actually holding up a lot of sensors from complying. And from a technical point of view, it had limited impact on its importance. So this is the type of information that we do as a national lab that we were sharing, and we actually think it'll help inform and improve both of the specifications. The other thing that we're focusing on, and this is a little outside the Zhaga, but it's very co-related, is that we're trying to hopefully get the North American market away from the 0 to 10 driver. I know in Europe that's less of an issue, but we have a legacy problem with that technology in the US. So we're requiring this D4I driver as a requirement. Again, the benefits there are just numerous. The previous presentation alone showed some of the examples of some of the data that you're going to need. And that's can come directly from the D4I drivers. So this is some of the things that we're trying to voluntarily get manufacturers and end users to pull the market there to the smarter digital drivers. And then one of the other reasons why we think the D4I driver makes a lot more sense is that really it's a standardization within the luminaire, which is great for sustainability, but allows for a lot of maximization of all the communication outside the luminaire. You can still communicate beyond all those things. And so by focusing on an intelligent driver with a standardized sensor interface, you're really dialing into two major issues while not limiting choices. This is a final slide in case you're wondering what the differences are between these two programs. I do appreciate you letting me really pitch a North American focused thing. So this IoT challenge is really trying to be very close to market. We're only focusing on the driver and the sensor, and at least in North America, we're seeing more D4I drivers available. It's meant to only be really kind of go for 1 year and pull that market quickly, whereas the Elprize is really reaching for the future. It's looking for a number of performance aspects, but also circular economy and sustainability, as well as some other equity issues. And so it's a much bigger, farther, harder reach. So it's a kind of a comparison of a couple of different voluntary programs that are currently in North America. This is my contact information. Would love to follow up and any questions, or if you have information you could share that I missed.